In this video, we're going to look at how we can multiply and divide complex numbers very easily if they are in modulus argument form. Just a reminder what modulus argument form is. So here, for example, if z1 is equal to r1 brackets cos theta 1 plus I sine theta 1, this is modulus argument form. The argument is the angle theta, normally in radians, and the modulus is the r1. Likewise, if z2, another complex number, is r2, so this is a modulus. Cos theta 2 plus I sine theta 2 is the argument here. So both these z1 and z2, these two complex numbers, are in modulus argument form. Okay, there's quite a long proof here, which I'm going to let you work through your notes in your own time. z1 upon z2 is equal to this upon this. So the r1, r2 comes out the front, so it's pretty obvious that the argument is, the modulus of z1, z2 is going to be r1, r2. Go through this process multiplying this out as you would. So cos theta 1 times cos theta 2, cos theta 1 times I sine theta 2, I sine theta 1 times cos theta 2, I sine theta 1 times I sine theta 2. Remembering I times I, or I squared, gives you minus 1. And it will tally up to be this. So cos theta 1, cos theta 2, minus, if I group the real parts together, cos theta 1, cos theta 2, minus I sine theta 1, I sine theta 2, plus I upon sine theta 1, cos theta 2, cos theta 1, sine theta 2. And this thing is equivalent to cos of brackets theta 1 plus theta 2, and this thing is equivalent to sine of brackets theta 1 plus theta 2. As I said, go through that in your own time, but the result is when you multiply two complex numbers in modulus argument form, you multiply their arguments and you multiply their modulus, I should say. I'll say it again. When you multiply complex numbers in modulus argument form, you multiply their modulus and you add their arguments. Okay? The same thing we can show when we divide. So when we divide complex numbers, if you have your z1 and your z2, again, I'm not going to go through this one. Only thing I want to say is to divide complex numbers, remember you multiply top and bottom by the conjugate of the bottom line. So the conjugate of the bottom line was cos theta 2 plus I sine theta 2. So you multiply top and bottom by cos theta 2 minus I sine theta 2. And you get this as a result, which is going to be equal to basically you divide complex numbers in modulus argument form, you divide the modulus, and you subtract the arguments. Okay, so the two results which are important for you, you have a result here in this box, and that's when you divide complex numbers. So for two complex numbers, z1 and z2, modulus of z1 divided by z2 is the modulus of z1 divided by the modulus of z2, and the argument of z1 over z2 is the argument of z1 minus the argument of z2. So that was for the dividing one, and also this is for the multiplying one. So for the multiplying one, this is what is important. So highlight those two results in some way, shape, or fashion for yourselves. It says for two complex numbers, z1 and z2, the modulus of z1 times z2 is equal to the modulus of z1 times the modulus of z2, and the argument of z1, z2 is equal to the argument of z1 plus the argument of z2. Okay, we're going to go on now and look at two examples, I think it is, on these, and then we'll be ready to do some questions. Okay, first example we have, it says find z1, it says z1 is equal to 3 upon cos of 5 pi over 12 plus I sine 5 pi over 12, and 4 cos of pi over 12 plus I sine pi over 12. Find, first of all, the modulus of z1, z2, and the argument of z1, z2, and hence write z1, z2 in the form r cos theta plus I sine theta, and then in the form x plus iy. So we will get started with that now. Okay, so first thing, A, part 1, we're just going to say our modulus of z1, z2 is equal to the modulus of z1 times the modulus of z2. So in this case, it's going to be 3 times 4, which is going to be equal to 12. For part B, it asks you for the argument. So your argument of z1 times z2 is equal to the argument of z1 plus the argument of z2. And in this case, that's going to be 5 pi over 12 plus pi over 12, which is going to be 6 pi over 12, which is pi over 6 pi over 12, which is pi over 2. Next bit says hence, this is dead easy. Now once you've got this, it says hence write your z1, z2 in the form. So we'll just say in the modulus argument form, so z1, z2, we know our modulus is 12, and we know our argument, it was pi over 2, so cos of pi over 2 plus I sine of pi over 2, and that's it done. There's nothing else you can do with that. Part 2 of this question says to get it in x plus iy form. So that means just multiply out this thing. Basically here, this gets multiplied out to give you 12 times cos of pi over 2 plus I times 12 of sine pi over 2. Cos of pi over 2 is going to be 0, so that's just going to be 12 times 0. Here, that's going to be I times 12 times 1. Sine pi over 2 is 1. So really what you're going to get is 12i, and that's it. Okay, it says in this one, express this horrible complex number division in the form x plus iy, and we will just get started doing this. So the first thing we're going to do is just divide their modulus. So it's going to be root 2 all over 2, and then it's going to be cos of, and it's going to be pi over 12 minus 5 pi over 6, and then plus I sine of pi over 12 minus 5 pi over 6. Okay. So as we go down to our next line, keep your modulus the same outside. It's just root 2 over 2. Then inside, all you're doing here is subtracting. So you have pi over 12 minus 5 pi over 6. Do this on your calculator. You'll get minus 3 pi over 4, and then plus I sine of, again, minus 3 pi over 4. And then all you do is, that's still, modulus outside is still root 2 over 2. Inside, then you just have your calculator in radians mode, of course, and then do cos of brackets minus 3 pi over 4, and that will give you minus 1 over root 2 plus I sine, and that will give you minus, sorry, that shouldn't be there, get rid of that. Get rid of that line. I'll tidy it up in the proper notes. That's going to be equal to root 2 over 2 upon minus 1 over root 2 plus I, and then sine of minus 3 pi over 4 is going to be minus 1 over root 2 as well. And we'll go on down, and all you do then is multiply in by your modulus, which was root 2 over 2, and that's going to give you minus a half I. And if we just check and see what we were asked to do, we're to get it in the form x plus iy, and we have done that. Okay, there's questions there for you to do as well from the NXL book, exercise 2D, questions 1A, 2, 3A, C and E, and then 4A and C.